Let's look at 22 because it just looks interesting. Limit t goes to infinity. T minus t root t all over 2t to the 3 halves plus 3t minus 5. What's happening up top? T minus t, right? Something like that. But isn't that infinity minus infinity? What's infinity minus infinity? Infinity minus infinity is, I have no idea. It depends on the problem. I just don't know. It's indeterminate. I cannot determine what that is. It's not 0. Could be 0, but it could also be infinity. It could also be 2. I just don't know. Over what? Infinity times 2 plus infinity minus 5. That should all be infinity, right? I basically don't know anything of what's happening here. And it doesn't even fall into any of the forms that I had, does it? Like, this isn't infinity over infinity. This isn't fixed over infinity. This isn't fixed over 0. This is kind of like a head-scratcher one, right? So I think to begin the problem, what I'm going to do is just do some algebra on this just to try and mess with it. First, rewriting this as the power on that t square root of t. Do you agree that that's t to the 3 halves? And if you don't remember why that's true, I'll just write it over here. T root t is the same as t times t to the 1/2, which is the same as t to the first power times t to the 1/2. And then you add the exponents. 1 plus 1/2 is 3 halves. Anyone have like an instinct of what to do here? Yeah, let's try that. Like, we know the denominator is going to infinity, right? In the past, when we had infinity over infinity, we tried to come through to try and reduce the highest power on the bottom, right? So let's just try it. I mean, we could wind up, you know, going into an abyss here, but as long as we don't break any rules, we should be all right. So what am I going to multiply top and bottom by? 1 over t to the what power? 3 halves. Shit, come on, come on. There we go. 1 over t to the 3 halves here. And you're going to distribute that through, right? What do you get on that first one there? Top left. T over what? T to the 3 halves, which is what? What's t? T over t to the 3 halves is the same as t to the 1 minus 3 halves, which is t to the negative 1/2, which is 1 over t to the 1/2. I'm using properties of exponents here, right? Because there's a 1 on that t. Anytime you have something to a power over the same thing to a different power, you subtract powers. So I should be getting 1 over t to the 1/2 minus what? One, right? That second distribution through there, they just cancel each other out. T to the 3 halves over T to the 3 halves, that's 1. Over, what do we get on the bottom? 2 plus 3 over T to the 1 half, then minus 5 over T to the 3 halves. I think this is going to work, because let T go to infinity now. The first one there, the the 1 over T to the 1 half, isn't that the square root of T? So isn't that the square root of infinity? That's fixed over infinity. What does fixed over infinity go to? 0, right? And then minus 1. So I'm getting something that looks like this. A minus 1 on top, and then on the bottom, the 2's still there, plus 3 over infinity, right? Fixed over infinity goes to 0, minus 5 over infinity again. So 0 again. So you get what? Negative 1 half. Y'all doing all right? I mean, you're just going to have to get your hands dirty at home with these things. I think we'll do one more. Limit x goes to infinity, x squared minus x to the 4th. Oh, you know what? This one, we'll have to do one more after this. I'm just trying to help you for your homework, but this one's not hard enough. What are you getting as you plug infinity in, though? You get what? Infinity minus infinity. So infinity minus infinity is, yep, they'll both be positive, though. No, the minus is in front, though. So the minus is, you know, you do the x to the 4th first, that'll be positive, but then you're subtracting it. So no, we don't know, right? Anyone see it? Good. You can factor out a what? X squared. And when you do that, you'll be left with what? 1 minus x squared. Now that changes the game, because now what you're getting is, what's infinity squared? Infinity. But now instead of subtraction or addition, you have times, what does this become? 1 take away infinity, which is, what's 1 take away infinity? Negative infinity, right? The 1 has really no effect on it. If you do 1 take away an infinite number, it's going to be a negative large number. And now we have multiplication instead of addition and subtraction. So what's a huge positive number times a huge negative number? Huge negative. Negative infinity. So this one we needed to do a little factoring first. Turn the subtraction into a product. So here's the last one, I promise. What's the limit as x goes to infinity of the cube root of x minus x? So what's the cube root of infinity? Infinity still? So we are getting infinity, take away infinity again. Still don't know what that is. Do you agree with that? Do you agree with this? That the same? Can I factor that? What can I factor out of both of those? X to the 1/3. What would I be left with? X to the 2/3. Good. Because when you have the same base, you add the exponents. 1/3 plus 2/3 is 3/3. See how that one's basically the same problem that we just did, except you had to factor something out that's a little more interesting than just x squared? Okay, but it gives us the same result. Because the first one goes, cube root of infinity is infinity. Then we get 1 minus, well, that's the cube root of infinity squared, so that's infinity. So we still get infinity times negative infinity, which is negative infinity. Okay, I think we're good. I think you can handle your homework for that now, hopefully. And that does it for chapter 1. Limits and stuff. What should we do? What should we do?